Hey everybody, this is Larry. This is me trying to do a bonus problem that I haven't solved yet. Yeah, let's take a look. Let's go. Sum of two integers. This is a weird. I guess I haven't done this one because it's just so silly. But today's Larry bonus problem is 371, sum of two integers. Medium problem with a lot of downwards, and I can expect why. Given two integers a and b, return the sum of two integers without using the operators plus and minus. And it could be negative. Yeah. I feel like I used to know this one just from like knowledge, but like you can do some stuff with bits and stuff like that. But it is just so like I don't know. Not gonna lie. Today, I don't know that I have it in me to do a stupid problem. Uh, I ran 10 miles hard today, and I'm just a little bit tired. But I mean, I think the way to think about it is that okay, instead of plus and minus, you have probably some of these operators, you know, the bitwise or the bitwise and you have some if statements and also maybe XOR, right? But yeah, I mean, the tricky thing is just about like okay, let's say you know you narrow it down to what you might call it, they're both positive just for now, right? Then what do you do? Well, you have two zeros or something. I mean, you could do like a logic statement, right? It and the tricky thing is about getting the carry bits, right? Because basically, if you do it, n will give you the bits that needs to be carried, and then so maybe you do a shift, but then it's just a little bit tricky, or otherwise would give you the thing. So you want to OR it, and then XOR it. No, is that right? I don't know. No, you want to XOR it. You don't want to OR it. You want to XOR it. The N will give you cases where they're both 1, so then you can get the carry bit, and then you XOR it to kind of get the bitwise addition, but you already have the carry bits, so then you shift, and then you maybe repeat. So then there's a loop there. So stupid. I mean, okay, so we could definitely do something like that, right? So basically, we'll play around with it, right? Let's just say this is, keep it this way for now, right? So then now XOR is you go to A XOR B, right? So this is the result of the addition if we don't have carry bits. The carry bits will be A and B, because if they're both ones in the same position, then they're going to be the carry bits, right? And then we want shift by 1 because we want on the next digit, right? So then now, yeah, and then now we want to add X and carry, and that's pretty much it, right? So while A is greater than 0 and B is greater than 0, eventually, I think, I mean, maybe I'm wrong on this one. Eventually, carry bit will be 0 just because you ran out of things to carry, so we can just do like A, B is equal to X carry, and maybe that'll be fine, I don't know. And then here we return, I think A is the only one that, because B should be 0, and then we return -1 for the other stuff for now. I just want to see if it works for positive addition, right? So that seems to work, yeah. And then if A is less than 0 and B is less than 0, then we just return, get some -A, -B, right? Yeah. or negative of this. Whoops. So yeah, so then here, and we could just do a test, right? -1, -2, -3, -4. Should be good, right? Ooh. Self.getSum. Right, so pretty straightforward, and of course, you may ask why this terminates. It's just that, you know, you run out of number of bits, so carry can only happen 32, not even, because it's only up to 1,000, not whatever. So this carry bit only happens up to 10 times, so it'll always terminate. Right, so this is pretty straightforward for now. Right, and these are the things that we can do. Okay, so that's addition. What is subtraction, right? Let's think it through, right? Okay, so I mean, subtraction is a little bit, oh, it's not necessarily subtraction, it's an addition with negative numbers. So then now maybe we can at least simplify it a little bit, so that we want a minus b, but then it could be negative, right? So maybe we don't, we want yeah, so if how do we want to write it? Yeah, if, oops, we want something like if this is what we want to solve, right? Maybe yeah, I mean, that's fine, right? If this is true, then that's good. So maybe we'll just do it the other way, right? If this is less than, a is less than b, then we return getSum, or self.getSum, ba, and these are the same. We don't change the sign, so this should be good. So then now one of them is negative, right? So then now we have one of them is still negative, but absolute a is greater than absolute of b, right? So then now now we can just do a regular subtraction from b to a on absolute value, right? So now we can say we want to solve for this, and then we just take the signs of a, I suppose, right? Yeah, because a is bigger than b, so then now we want this, because the opposite, yeah, and then we want the sign of a, right? So then, yeah, we can do something like if a is greater than 0, then yeah, then this is positive. If a is less than 0, then this is negative, right? So yeah, so okay, yeah, so is negative is equal to a is greater than, it's positive, I guess, but okay, right? Okay, so then now we solve for this thing, which simplify things a little bit, hopefully. Okay, so then now I think the way that, I mean, I kind of skipped a little bit on why this works, is that I'm just trying to think about it bit by bit, right? And for addition is a little bit easier, because here I'm just thinking, okay, well, there are only 4 cases, right? I mean, there's still gonna be 4 cases. I'm going with addition for now, just to be clear, because then you have 0, 0, then nothing changes. So then the answer is going to be 0, 1, 0, the answer is 1, 0, 1, the answer is going to be 1, 1, 1, the answer is going to be 0. So this, except for there's a carry bit, right? So this means that, you know, and just looking at this bit by bit, and you can actually do a recursion here, I suppose. We don't even need a while loop, but that's fine. But yeah, looking at this is just an XOR on this side, but we have to do the carry bit. So in order to get a carry bit, we get a carry bit if it's all ones, and then we can shift to the left or multiply by 2, which is not one constraint, because we know that the carry bit is on the next one. So then you want to add all the carry bits together with the extra number, and that's basically why we set a is equal to b, because we want to do it again. You can, like I said, you could do it recursively by like doing return self.getSum of a b or something like, of x and carry is basically what I'm doing. This is slightly cleaner, I suppose. I don't know if that's true, but okay. So then now what do we want to do for subtract, right? So the same idea. Sorry that I didn't go over it before, but yeah, I just kind of did it in my head. But yeah, 0, 0, we have 0, right? 1, 0, we have 1. 0, 1, we have 1. But we have a negative carry, right? And then 1, 1 is just 0. So again, looking at this, this is going to be, this is another XOR. So we know that the digits should be an XOR function, right? So maybe we have something like this. But then now we have to figure out how to get the negative carry bit, right? Oh yeah, so maybe here we will A is equal to absolute A, B is equal to absolute B, just to make it slightly easier, right? And then we have X is equal to A XOR B like last time. But then we have to figure out the negative carry. And here, let's see. So this is a 0 and this is a 1. So maybe we do... so yeah, the way that I would play around is just, okay, I think if we knot this, if we knot the left side, so this is AB and not A. So yeah, okay. Not A is going to be, and this is like a truth table thing, right? Not A is, let me actually write it on its own thing because, I don't know, maybe it doesn't make sense. Because that's for the thing. So not A is going to be 1, 0, 1, 0, right? And then B, we have 0, 0, 1, 1. So then now we can do an AND statement here, right? So that's basically the idea. And again, now that we have an AND statement here, then so this is a negative. So we have, yeah. Now that we have another AND statement here, then now we have a number that's all negative carries. And negative carry is of course just a subtraction, right? So so maybe you could say negative carry is equal to not A and B, right? And then now we're trying to and another way to interpret negative carry is that well, actually, do I have to shift? Yeah, we have to shift to we have to multiply this by shift to the left because we were borrowing one from the previous, right? So yeah, and in a negative carry kind of way, we're also trying to subtract x from negative carry. So we can maybe do this, right? So then yeah, we do the same thing here, which is while a is greater than 0 and b is greater than 0, we keep on subtracting. Yeah, and then here we do again ab is equal to x negative carry, and in theory at the end we should have negative we should have a. We should test this one. This one I'm a little bit less confident about terminating because in addition, at least this can be 0 eventually. I'm not quite like, what if negative carry is bigger than x, right? I don't know if I'm super convinced yet, but yeah. Also, we forgot it is that if not is positive, a is equal to negative a, but that's yeah. Okay. I mean, obviously we need a test, so we have say negative 10, 5, 10, negative 5, 5, 10, negative 10, negative 5, 10, right? Something like that. Okay, so it looks good for the negative examples. To be honest, I wouldn't be surprised if this is a little bit imprecise, just because in my head I can wrap around it, but maybe I can visualize this a little bit, right? So x equals a exclusive b. It's gonna have n bits, not a and b. I think this thing gets a little bit smaller every time, but I don't know. Let's give it a quick submit. Ooh, oh, I think I just didn't handle the 0 cases, because here we have this thing. Wait, no, that's not true. I see. I think I don't do the old. I think the thing is that, yeah, this could be. I missed a case. There is a case in which A and B is like, so if you have and there's a actually easier example. What is a easier example? So yeah, let's just say this is 8 and this is 8. Yeah, and this is wrong because we expect, wait, where did I put it? 8 8 is the last one, right? Yeah. So because 8 and 8, the XOR is going to be 0. Carry is going to have something, but we don't care about it for whatever reason. But we terminate it. So yeah. So I guess we have to do like So A could be 0 if everything is in the carry. So then yeah. So then if A is equal to 0 and carry is greater than 0, then A is equal to carry. Maybe that was fine. I suspect there's something similar for this just because I assumed that A would be correct, but I was wrong on this one. And yeah, and you could probably even just do a very easy like 8, -8. Though you may get lucky on the 0, honestly, just because this is now 0. Not 8. No, actually, I guess this is, I don't know. I'm going to YOLO submit just because I'm tired and lazy. But yeah, I wouldn't, because I think actually in the case where A is equal to B, that's why I kind of have some confidence. So it's not like a YOLO, but a slightly more YOLO is that, yeah, I in this case, this would actually be perfectly 0 as well, right? So because A is equal to B, and if A is equal to B, then not A can share no digits with B, so this is 0, so they're both zeros in that case. But here I was just wrong. Because I assumed that yeah, I assumed that A and I just kind of was incorrect. I just thought that carry would go to 0 at some point, except for this one edge case where A is equal to B. So yeah. Yeah, and yeah, what's the complexity here, right? It's gonna be linear time because for every digit, that's the length of this while loop. But you can maybe say it's n squared because oh no, it's only shipped by one. No, but it's still, yeah, maybe it's n squared if you want to count the bit by bit. I'm curious what solutions they have, right? So yeah, so you have this thing, reduce the number of use cases. That's basically what I did, right? Okay, sum of two numbers, XOR without carry. So they basically did what I did. So without while, I called it negative carry, but I guess it's the same idea, or like same, or different phrasing. Maybe it's a better phrasing, but yeah. Okay. Yeah, their code is a little bit shorter, but I mean, I guess they use A times B thing to be kind of funky, but how did they? Is this right? I guess so, right? But I'm just trying to see, looking at this thing and coming up with how do they handle the A is equal to B case, the one that I failed, basically, right? Because I don't see what they did. Like they don't. Am I missing something? Oh, I see. I see. The difference, actually, yeah. The difference is that I see. That is a better way of handling it, actually, than the way that I handled it. Which is that I did this if statement, which is, I guess, fine enough. But basically, if, yeah, I don't know why I didn't think about that, actually. If carry is something and x is 0, we can still terminate. It's just, in that case, yeah. So you have something like this. So then now you do one more loop of carry plus x into x. So I guess that's how that fixes. Yeah, okay. Yeah. Okay. I mean, I guess that's a little bit cleaner. The other stuff is mostly, whatever. It's just, well, I think we have the same idea. Yeah. I don't know. It's it's fine. I don't think this is an interesting problem. It's just like you just have to know what tools do you have, right? But as soon as you realize what tools you have and what they're doing, yeah, I think it is actually a good practice for people who ask me a lot about bitwise operations. I think it is actually a reasonable practice, but I don't know. For me, I don't really care that much about it. That's what I have for this one. I think back in my day, like a long time ago, these kind of what I call brain teaser trick questions would show up on interviews, but honestly, I don't think they do as much nowadays. It's just a little bit weird. But yeah, that's what I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to good mental health. I'll see y'all later. Take care. Bye bye.